Dear students, now I am going to discuss acclimation, acclimatization, temperature maintenance in ectotherms. So, what are the differences between acclimation, acclimatization, and adaptations? So, animals develop various adaptive mechanisms to minimize the impact of temperature on their systems. These responses are termed acclimation, acclimatization, and adaptations. So, what exactly acclimation? Acclimation is the process by which an animal adjusts to a change in its environment, or the ability of living things to adjust to the changes in the climate. So, it is a short term adaptation, what you can see. So, if the animal is placed, if it is in the 30 degree, suddenly it is placed in the 40 degree. So, a small change will occur in the animal to adjust to the 40 degree centigrade. Similarly, if it is placed in the 15 degree centigrade, there is a adjustment you will see. So, this is of short duration, this is not adaptation. A small adjustment will take place. So, that helps the animal to adjust to the changed climate, or the temperature. So, acclimation is a short term structural response developed by the animal to cope with the temperature extremes. Acclimation is a short term adaptation induced by unusual extreme temperature in the environment. Acclimation to high temperature is faster than that of low temperatures. So, here in this you are seeing, so this is a wood frog. Wood frogs acclimated to the lower freezing temperature during autumn. So, what happens, you can see the the autumn is followed with the harsh the winter. So, when the autumn onsets, immediately the wood frog there is a small changes occurs in the body of physiology of the wood frog. So, the metabolic changes that occur to protect the freezing temperature. So, the stored glycogen in the liver converted into glucose and gets circulated. That helps the it to keep the cells from completely dehydrating and shrinking. So, this is the process. So, it is a small change, metabolic change, where you can see the circulating glucose will preventing from shrinking of the cell or else dehydration. So, thereby this will survive the onset of the winter during the autumn season. So, this is called acclimation. Similarly, you will find if a frog reared in or else any animal reared in 25 degree centigrade, if you place it into 15 degree centigrade, suddenly it will adjust to that temperature, and it will able to sustain. So, that is what you can see acclimation. Acclimatization. Acclimatization means adjustment of animal for changing environment or season. So, here the difference between acclimation, acclimatization is a coordinated response to several related stressors. For acclimation only for the temperature, but acclimatization along with the temperature, the related stressors like the humidity and the photo period, the time of exposure to the sun, all this you can see. So, this is what you can see, the acclimatization. Acclimatization involves a number of interacting physiological processes or physiological adaptations that occur during repeated exposure to a hot or cold environment. These physiological adaptations during hot include increased sweating, greater sweat production, reduced electrolyte loss during sweating, stabilization of the circulation, increased skin blood flow. So, all these changes, it is there are several changes with related to the temperature will occur, and this is totally called acclimatization. Acclimation and acclimatization act to improve the animal fitness to the environment. So acclimation and acclimatization are induced by the environment and are considered phenotypic changes, not genotypic changes, and the responses decay if the stress is removed. Both acclimation and acclimatization, it is a time being changes, adjustment, what you see in the animal body to adjust to the changed climate or situation, and this is a phenotypic expression, and it may change, or it may, once the favorable or temperature occurs, this it ceases, or these changes will decay or they will diminish. So this is not a genotypic change. So whatever the genotypic change, that will be the adaptations, true adaptations. Okay. So you will find the example you will find in the golden hamster here. What you see, it's a rodent. It prepares for hibernation when the environmental temperature drops 15 degrees centigrade. So once it drops from 25 to 15 degrees centigrade, there is a lot of changes occurs in this animal. It prepares. So next, the winter is onsetting. So now I have to go for hibernation. For all this hibernation, there are so many changes will occur. Fat accumulation, then there is a more fur going to develop. So all these you will see the changes. So these these are called acclimatization. What is exactly the adaptation? That involves genetic changes to an adverse environment persist over several generations. The species will adapt or developing some structures. So it is the one, the genotypic change, that is called adaptations. Now the endotherms, they have thermoregulatory system which maintains constant temperature irrespective to the changes in the environment. What happens to the ectotherms or poikilotherms? There is no thermoregulatory system there. Then how? But they have to be, they cannot change their body temperature according to the changes in the environment. So for example, they have to have some behavioral adaptations or else some structural adaptations, so that they can withstand the changes in the temperature. So these are the one, how ectotherms or poikilotherms, they adapt to the changing temperature or temperature extremes, you can see. So the ectotherms, that's you can see the meaning of the ectotherms. Ecto means from the outside, it maintains the temperature. Temperature maintenance is very important, because all enzymes, most of there are, every cell, they have something like 4,000 and odd enzymes activity, biochemical reaction or metabolic reactions. So all these reactions are enzyme catalyzed reactions. All these reactions will occur at the optimum temperature between 30 to 40 degrees centigrade. So that temperature, you will find the metabolism will occur. So all organisms, they maintain certain amount. So they don't, even though they don't have thermoregulatory system, they are externally, they maintain this. So inbuilt thermoregulatory system, endotherms. So through outside regulation, ectotherms. So how they maintain? So poikilotherms or ectotherms, in the absence of thermoregulatory mechanism, some extent of temperature maintenance essential for enzymatic reactions which carried out through behavioral and metabolic adaptations. So those are absorption of heat from solar radiation, or from the sand or from the rock. You might have seen during cold environment, insects such as beetles, desert locust, this is a desert locust, and they are butterflies, they absorb heat from the solar radiation or else through the sand by absorbing the heat radiations from the sand. So similarly, you will find snakes, lizards, crocodiles often found basking. You will see crocodiles basking under sun to increase their body temperature. So in the seashore animals and desert animals absorb heat from the sand and rock. So, the raising body temperature through metabolic or muscular activity. So, you will find the fishes in the water all the time doing muscular activity, actively moving here and there. So, this increases the body temperature, so that the enzymatic reactions will takes place. So, see, they the insects also, they are always fluttering their wings. So, the muscular activity, then or else they will be living in the groups, you can see. So, it maintains the temperature is not dissipated outside, it will be maintained in the circulating in the within this, you can see. So, these are all the adaptations you will find in the Poikilotherms or else in the Ectotherms to maintain certain extent the temperature in their body. Exoskeleton barrier to prevent the heat convection. So, overlapping scales you will find in the case of snakes, lizards. So, spiny skins in rhinosoma, desert lizard, then crocodiles, exoskeleton of insects. So, all these act as a barrier for heat convection to the environment. The heat, whatever our atmospheric heat not get into the body because of these overlapping scales. Then the shape and the compactness of the body, coloration of the body, so they also prevent heat dissipation or else absorption. So, in the case of frogs, toads, the compactness of the body parts, the shape and size, so all these help to prevent heat loss through convection. Then aggregation to prevent heat convection, you will find so many animals, they aggregate in large numbers, the school of fishes, flock of birds, so even the snakes. So, this they prevent heat convections, thereby they maintain temperature in their body. Similarly, if there is a too much heat, there is a fanning, you will find in the case of insect colonies, bees, wasp. During extreme heat, worker bees or wasp, they cool the hive by through fanning. So, this is in the case of frog, the coloration. So, that is preventing the convection. So, the biological clock, animals set their biological rhythms to daily rise and fall of temperature and also seasonal changes. So, you can see the behavior of the migration, then estivation, hibernation, all these depends on biological clock or the change in the temperature during different seasons and also in the the daily changes. So, depending on that, their activity cycle operates, it is called daily torpor. So, the panting, crocodiles and alligators, you will able to see they when they are during summer, they panting, even the dogs they do. So, this thereby lot of temperature, the build up heat will be dissipated outside, you can see. Then the estivation and hibernation. Estivation is summer sleep, hibernation is the winter sleep. Poikilotherms avoid extreme cold by hibernation, going for the long sleep for 2 to 3 months during freezing cold. So, they switch off their metabolic clock or basal metabolism. They switch over to basal metabolism, the body heat and even the respiratory rate, all this you can see, that is called hibernation. Similar you will find in extreme summer, estivation. They remain as a tough bodied structure to withstand the severe summer. So, this is what you can see, estivation. Some ectotherms are so good at using behavioral strategies for temperature regulation, so that maintain the fairly stable body temperature. You will able to see here how the fanning, the honeybee. Here you will find the spotted turtle. So, this is you will find during summer. So, this is estivation, this is panting, this is hibernation, and also in the case of snails, they you will find they avoid extreme temperature by hibernate or estivate. So, this is about how invertebrates and poikilotherms, fishes, amphibia, reptiles, they avoid cooling down of their body, or else you will find they maintain their body temperature to certain extent through behavioral and physiological changes. Thank you.